Hey guys, my name is Jason with Mount Baker Mining and Metals, and on today's video we're going to be running some electronics and printed circuit boards through our turnkey PCB system behind us here. So we'll go take a look at the samples, we'll take a look at the system, and then we'll get to running. So we've got several different samples to run today, and I think I'm going to put them in this order. So this will be the first sample, and these are shredded up boards, but look at all the gold fingers on them and little gold foil. We got 2 buckets of these, and this is a beautiful sample. Man, I love getting samples like this where they're all shredded up, and it'll be real easy on the hammer mill, and it'll go through fast and onto the table, and we can get all this stuff out of there. There should be some copper plates laminated in there as well. So this one's going to be, it doesn't look like there's many components on these. It looks like they've pulled all the components off. But we'll run this one first. And then we've got kind of a mishmash of stuff over here. This is several different samples. I'm going to break them up kind of as follows. I think I'll run the boards, 1, 2, and 3 buckets of boards together. And that way we can collect the number 1, number 2, and number 3 samples off the table. And you can get those assayed. Then we have a sample of these connector pins here. And so these are those gold coated pins that people go after. So we got a bucket of those. And then over here, I think these are called flat packs. We got some of these as well. So we'll run these as its own little sample. I have a little bit of confession to make. I'm not a recycling guy, a PCB guy, so I don't actually know what this stuff is called. So I think those are pins. I think those are flat packs. If I'm wrong on those, correct me, so I can learn something on the video today. But yeah, so we'll get those. And then the last sample is in this barrel, and I'm not going to stick my hand in here without gloves. But this is shredded up, I think he said lithium-ion batteries. And this is, there's copper and aluminum, and there's a little bit of steel in here. It actually looks like quite a bit of steel. But if you get up close, he says there's also some black metallic powder in here that I think we can recover on our shaker table. And he wants to separate all the blue plastic light junk that's not worth anything from the heavier metals. So we're going to give this one a shot as well. We'll take a little walk through our system here. This is what we call our small turnkey PCB system. This is a 16-inch by 12-inch hammer mill. It's got a rotor on this shaft here that spins around in this case. A bunch of hammers attached to the rotor, and they just beat anything that goes down the chute here. Beat it up. There's a screen that goes all the way 180 degrees along the bottom of the mill here. And this screen has 1.2 millimeter slots that are about 1 inch long. And the whole screen's covered in those. And then it comes down this chute onto one of our 4-foot by 8-foot shaker tables. Everything that's light, a lot of this stuff will float in water, but light, fiberglass, plastic, anything that's has a density of about 3 grams per cubic centimeter or less will come down here into the number 4, the waste trough. The metals that are heavier, but still not heavy enough to get up the ramp here, aluminum is a good example, will come down right here at the base of the ramp and into the number 3 middlings port. I'll get a bucket under there to catch those. And then all your copper, your steel, anything denser than about 5 grams per cubic centimeter. There's a little ramp built in the table. You can see these 4 long grooves. Those metals will come up the ramp under this diagonal water bar onto what we call the cleaning plane. There's another little flat spot up there. And they will come down into the number 1 and the number 2 high-grade concentrates. And you'll see a little bit cleaner, higher grade stuff come down in the number 1. More of the dense stuff will come down here. If there's a huge volume of copper or steel, a lot of it will go into the number 2. We have our 2 safety grooves here in the table that catch anything that kind of overflows down here. It'll bring it over to the number 2. So unless the table is completely overwhelmed with copper, which I have seen before, but almost all the copper and the gold and the dense metals will come down here, and the light stuff will come down here. But if the table gets overwhelmed, you'll get a little bit of copper contamination into the number 3. This is literally just a plywood tank that we built and covered it in a pond liner. We recirculate all the water through the system again. A lot of people are very concerned about the environmental impacts of the water. So we recycle all the water here. Nothing gets discharged. And when we dispose of the waste, we let the tank evaporate and let the stuff dry out and then shovel it out and dispose of it correctly. So there's no discharge water to the environment. As everyone has said, there's lots of nasty stuff in these boards and these batteries. So we want to keep everything contained here. We have 2 pumps. There's a 3-phase pump here that pumps a large volume of water up into the back of the hammer mill here. And that helps the crushing and the stuff that flows down onto the table. We have another pump over here that feeds the water bars to the shaker table. And everything, all the water flows down the table. The table is slanted downhill towards the number 4 tailings. And all the water flows off, carrying anything light with it down into the number 4 to be recirculated through the system again. So we'll get this thing fired up, and we'll see what we can do with these samples. Well, we got everything pretty much cleaned off here. Let's take a look at the number 1 and number 2 down here. And we'll see what we got. We'll also take a sample of number 3. So let's take a look at all 3 of those, then we'll bag them up and get them sent back to the customer. So here's our number 1 bucket. And it's always amazing to me how heavy these are, even though there's not hardly anything in them. I'm just decanting the water off here. And here is, get it to focus here. Kinda. There's the metal fraction, the number 1 fraction. And a lot of that stuff is copper. And then those gold, I don't know if they're gold foil or gold plated something. But that is where all the good stuff is. So there's number 1. This is the number 2. Pour that in there just to make it go faster. And this one was getting a little bit of fiberglass in with it at the end there. You can see right on the top there's some fiberglass that snuck across those 2 safety grooves. But this one doesn't have as many big pieces, but it's still almost all metal. There's a few little pieces of fiberglass, green board that probably have copper still laminated to them. But I mean, that's, you know, looking at it, that's 98, 99% metal there with just a little bit of contamination in it. Now I'm going to rinse my hand off here so we don't get any contamination in our number 3. Let's see what this looks like. Got to be careful. This one is usually mostly fiberglass, not a lot of metal. You don't want to pour off a bunch of the good stuff, or the sample, I guess, not necessarily good. There we go. Let's see, this is mostly that green board. And if you look real close, it's hard to tell on the camera. I can't even tell looking through it. Let me look past the camera. I don't see any copper at all. There's a few little silvery flakes that are probably aluminum. But this is where the junk went. And I took a sample of number 4 there, and it was just dust. I mean, it was just super, super fine, kind of like this gray stuff here. It's just little bit of sludge coming out of number 4. So most of the waste in this sample went to the number 3. So we'll get that bagged up, sent off to the customer. Let's get another sample going here. Okay, one more quick look here. This is the number 1. I think it's a little easier to see through the bag rather than in my hand. A bunch of pins, little rolled up pieces of copper. There's a bunch of that flake, that gold flake and stuff. So there's number 1. Here's an up close look at number 2. A little more aluminum or silvery colored metal in there. The copper pieces are finer. There's a little bit of glass and green board in there. There's a piece of green board with copper around the edge. So that's the number 2. And then here is the number 3. And like I say, I don't see any copper. That might be a little piece there with some green board on it. Black plastic stuff. A lot of green fiberglass. I don't know. You see any copper in there? I don't see hardly anything. Wait, what was that? There's a little piece maybe. But, I mean, hugely, hugely clean. 99.99% clean copper and 98% metal and, 100% metal, 99.9. So between just those 3 fractions, 1 and 2, got almost all the metal, and number 3 got almost all the waste and hardly any metal. So there you go. There's 1, 2, and 3 from that first sample we ran. So here's something pretty cool with those black flat packs. All this stuff right in here is gold. And there's a gold line all the way down the edge of the stuff there going into the number 1. So that's a pretty nice little band of gold. But it's super, super, super fine. Very, very small. So there you go. I got some gold out of those black flat packs. Well, I'll get the table kind of brushed down and get all the stuff into the number 1 and number 2 down there, and we'll take a look. There's that gold line coming down the table right into number 1. Here's our flat pack results. And I am really out of my depth here, so I'm probably going to just ask more questions in this section than have answers. But we'll take a look at our number 1 here first. It looks like a lot of those pins came through into the number 1. And it also looks like they're maybe copper pins coated with that silver stuff. Is it actual silver metal they're coated with, or is it like a tin coating? Let me know on that. But this is where all the gold went, all that fine gold. And again, another question for you guys, is that gold hair wire in there, or are those little gold connector plating stuff, or where did that gold come from in these flat packs? Here's the number 2. There's a little bit of that black stuff that got into the number 2 here, but a lot of copper. It's still pretty heavy and dense, and it looks like a little more of that silver colored metal, or that gray colored metal made it down in here. So that's number 2. And then this is the number 3. Again, just like on the previous sample, almost all the waste went into the number 3. But looking up close, you can see very little metal in there. A little few copper flakes and stuff, but it chewed those things up pretty good. And they all came down in that big band right down into the number 3. A little bit of contamination from the fiberglass, but so there you go. There's flat packs 1, 2, and 3. Okay, next we'll try these little plugs and pin holder things. And I don't know how much of it's going to make it into this video, but it is extremely hard to load that thing and film it at the same time. So I've tried a few times to show me putting stuff in there, but I'll just put these in the hammer mill when it's running, and then we'll get a shot of them running on the table and see how they do. Well, here's our plug sample. Plugs number 1 is almost all pins. You can see there, they all came over in the number 1. Most of them are still whole. Here's number 2. Some pins and little pieces of wire and stuff. And a little bit of that thermoplastic, black plastic got in there. But what I noticed is while I was letting the table clean itself off, as the copper ran out, some of this thermoplastic started filling up the safety grooves and coming over. So I think that's where most of the contamination came in this one, is I just let it run too long without enough copper on it to kick the plastic out of the safety grooves. And then here's the number 3. And there again, I don't see any copper. It's pretty much straight plastic. And it just chews it up into little tiny pieces. And they come over the table and down to the number 3 port. So that one worked really well also. Okay, now we'll run these boards. Whole boards, lots of pins, plugs, flat packs, pretty much everything we ran earlier as individual samples. Now we'll get to run them all together. And here's our results from the boards. So this is the number 1 fraction, tons of pins, big pieces of copper, all metal. There's no fiberglass or anything in there. So that's just super high grade, valuable stuff. Then over here in number 2, not as many big pins and stuff, mostly copper flakes. I think that's from lamination copper between the boards, between the layers in the boards. And a little bit of contamination in there from some fiberglass and some of that black plastic, but just by the weight, it's still super heavy, so it's way high in metal content. And then here's the number 3 fraction. Oh, that's on the surface. But yeah, there's, I mean, I don't know. You guys see any metal in there? I don't see any metal in there at all. I think that's pink plastic. So it does a darn good job of separating the metals from plastic and fiberglass. So you can take whole boards, run them through the system, get pretty much all the values here and all the waste here. So here's that battery sample. And I wasn't going to run it through a 1.2 millimeter screen. I was actually going to change it to a quarter round hole. But then I got to looking at it, and the steel fraction in here, let's see if I can get a piece. The steel fraction in here is just super thin little foil stuff. And so I'm going to try, I don't know, half a bucket or 25 pounds or something through the screen we got in there. See if we can separate this plastic and the junk. Get, like here's a good example. Get the copper. There's copper in there that's valuable. There's some black stuff, I don't know what it is, that I think is also valuable. The steel's not valuable, but it's magnetic, so you can separate that out. And then all the blue plastic, the white stuff, the yellow stuff, that's all just garbage, and that should be light enough that it comes down into the number 3. But this is going to be an interesting one. I've never dealt with batteries before, and I think if I can get this to work, you could probably just hang a magnet over the high-grade end of the table and pull all the steel off as it comes out. Because you can see there, like there's a lot of copper in there, and whatever that black stuff is, if it's dense enough to come across, we should be able to grab that too. So let's try it. Let's run a little bit and see what happens. Well, we got done running the batteries, and I don't know if it went good or not so good. Here's a little snapshot with the table off. And this lighter colored stuff, I think, is actually aluminum. So if you saw it on the video, there was a band of aluminum coming down, and then there was a band of this copper, little copper flakes and black stuff. I don't know what the black stuff was. And then over here, there was, clean copper coming down. And so I think in number 1 and number 2 is where the copper and most of the black stuff went. Number 3, I think, caught a little bit of copper and all the aluminum. So we'll see how that goes. But if you could get it feeding really consistent through the hammer mill, you could put a splitter right here in the number 3 and divert the aluminum one way and the copper and the black stuff another way. But I'm just not familiar enough with batteries to know if you want the black stuff in with the copper, the aluminum in with the copper, or what. So I'm not quite sure. I need to talk to the customer a little bit more about the details of this one. But let's get the samples pulled out, put them in bags, and we'll see what they look like. And here are the batteries. So this is the number 1. And a lot of the bigger pieces of copper went in here. There's still quite a few pins. I think there was some contamination with the boards that we ran earlier. But any of the larger pieces of copper, steel from the batteries probably went in the number 1 port on the table. Here's the number 2. And there's some copper flakes and stuff in here. And a lot of this black stuff, this is like the bigger pieces of the black powder in those batteries. Again, I have no idea what that is. A little bit of contamination with fiberglass and a little bit of plastic in there, but this is mostly copper and the black stuff. Now, interestingly enough, it's heavy, but it's not as heavy as if it was all copper. So whatever that black stuff is, it doesn't seem like it's incredibly dense, not like copper. And then this is the number 3. There's a little bit of copper in here, a lot of aluminum, and a lot of that black stuff. And so I was mentioning earlier where you could set it up to where you could have a splitter on that tailings trough, or the number 3 trough, and you could split the aluminum to go one way and the copper to go another. So I think you could clean this up even further than it is. But there is the number 3. And so those are those 3 ports. I'm going to try and do this backwards. But the interesting thing about that battery sample was when I would put handfuls of stuff in, black water, it just turned super black and it'd come down, whichever way down is, into the number 4 port down here. And it just run down the table like it was, so fine that it couldn't settle out in the grooves. But whatever was large enough, it ran its way over into the to the ramp here and came down that way into the number 3 port. And so I don't know what that black stuff is, but I envision that if the fine stuff could be brought down into the number 4 and filtered out, if it's valuable, you could save it that way, and then the larger pieces could be captured in the number 3. So again, just, I know nothing about it, but that's kind of what I was observing. The other thing that I'd like to do is, depending on what the customer thinks of the samples we send back to them in this video, I might change the screen and make a little bit bigger screen, like a 1/4-inch hole, and try that and see if that helps with separating the aluminum and the copper and the steel a little bit better. But the steel, like we talked about earlier, you can just mag out. So there you go. That's the battery sample. All right, guys. Well, that's it for this video. We covered a lot of stuff in this video. We did boards, we did pins, we did plugs, we did flat packs, we did batteries. And I have a lot of questions about some stuff. I mentioned them in the video. If you guys could leave me a comment in the comment section and let me know what you think of some of my questions. Help me out, you guys that are into batteries. Let me know what's going on, what you see, what I could do differently, and same with the flat packs and the pins. So I hope you guys enjoyed the video. Thanks for watching, and we'll see you on the next one.